following terms. So DNA molecule, nucleotide, genes, chromosomes, base pairs. I know like last class we did the DNA puzzle. So we have an idea about the DNA structure. And what I want you to construct scientific explanation about the structure and different parts of DNA. And then we're gonna, what I want you to like describe in general the process of DNA replication. Okay? So let's do a review about the DNA structure. So DNA stands for what? So I'm gonna throw the ball and raise your hand when you don't want to answer. Okay.
Deoxyribonucleic acid.
Deoxyribonucleic acid. So, wow.
Sorry.
That's fine. So deoxyribonucleic acid. So is it DNA is a nucleic acid or nucleotide? Daoud,
It's a nucleotide.
is it a nucleic acid
Oh, it's
or
both.
nucleotide? So it is
Both.
nucleic acid, which is the monomer.
Oh, no, okay, it's a nucleic acid, but the monomer is a nucleotide.
The monomer is the nucleotide. Excellent. So, who can tell me what are the nitrogenous bases? We have 4 nitrogenous bases in the DNA molecule. 4 nitrogenous bases. Yes, Owen.
Guanine, adenine, thymine, and thymine.
Adenine and thymine. So we have cytosine, guanine, adenine, and thymine. So, what is the bond between the nitrogenous bases? What type of bond?
Hydrogen.
Raise your hand. Yes, Hassan.
Hydrogen bonds.
Hydrogen bonds. Are they weak or strong?
Weak.
Weak hydrogen bonds. Thank you. What are the backbone for the DNA molecule? We have 2 things. We have 2 things. Yes.
Sugar molecules and phosphate.
Sugar and phosphate molecule. Excellent. So we have sugar. What type of sugar we have in DNA? Is it glucose, fructose? Raise your hand. Yep. What I'm gonna give you now is a worksheet. Okay. And I want you to answer it individually. Okay, you're gonna have like 6 minutes. 6 minutes to do this worksheet individually, and then we're gonna discuss it. Okay. So you will have 6 minutes. I'm gonna put a timer. Please remember it's individual work. So you have 4 to 5 minutes.
Do we have to go into detail on the kind of sugar and use one specific for this question?
Yeah, if you please, when you're done, raise your hand so I know that you're done with the sheet.
Okay.
So, first partner will talk for 1 minute without interruption, discussing your answers, okay? And then we're gonna have silence for 10 seconds, and then The other partner will talk, discuss his answers or her answers for 1 minute, okay? And then after we're done, we're gonna discuss it all together, okay? So, first partner, 1 minute, talking without interruption, okay? So, 3, 2, 1, start.
Basically, the sugar molecules are the guys, so I go and they're made of a fine carbon. I skip the first question because I don't know.
Yeah.
We don't get enough work. For chemistry, soccer. Thank you.
Okay, why is why did they want each other with the
And you work? Silence for 10 seconds. Silence for 10 seconds. Okay, 1 minute.
What's this system? When you try to act like you know something.
Done, silence. No, that's called eyes on me, eyes on me, eyes on me. So, let's discuss it. So, we know that all cells contain what? Contain genetic material, genetic information. In the form of what? Which molecule? DNA. So, for the first question, which nitrogenous base is the complementary base for thymine? So we have thymine, which one is the complementary for, yes, Dawood? Adenine. So A binds with what? With T. A for adenine, T for thymine. How we could memorize it, like apple on the tree, or apple on the tree. Okay. Nice. And how many hydrogen bonds? They bond in 2. So, next question. Can you please read it?
Which nitrogenous base is the complementary base for guanine?
Guanine. Yeah. So, which complementary? Yes, Hassan. No, we don't need cytosine. Okay. How many hydrogen bonds between cytosine and guanine? How many? Please raise your hand. How many hydrogen bonds? 2, 3, 4, 5. How many hydrogen bonds? Yes or what?
Thymine 2 and 4. Cytosine and guanine.
3. Excellent. So adenine, thymine 2, guanine, cytosine 3. We have phosphate group and sugar. As we said, which type of sugar? Okay. The DNA molecule is in the shape of double helix and calls itself upon histone protein. Why are these features important to DNA? So let's think about the shape of the DNA or the structure of the DNA. It is what? Double helix. It is twisted. Is it long or short? What do you think, DNA? Is it too long or too short? Very long. So So why do you think DNA should be coiled around the protein?
To save space.
To save space. So we have a long DNA strand. We need something to coil it around, to condense, to save space. And this protein, we call it what? Histone.
Good job.
Histone. Is it clear? Fist to 5. If it's clear, please raise your hand. Give me 5. If it's not 4,
Oh,
it's not 3.
we said it all.
5, 5. I see 5. I see 5 or 4. Okay, 5.
We can.
4. I see 4. So, which part is not clear for you?
It's all clear, it's just like it's so strange.
Yeah. So think about the DNA molecule. DNA molecule is too long. So how are you gonna have it in your nucleus? So there should be something that coiled around, so that could be condensed in your nucleus. So it is twisted, and at the same time, it is coiled around the protein, which is histone, to save more space. Is it clear?
Yeah.
Yes.
Great. So, last question. What type of bond can be found between complementary nitrogenous bases? Why this type of bond significant to DNA? So, what type of bond we have between the nitrogenous bases? Raise your hand. Yes. Hydrogen bond. So as we said, hydrogen bonds are weak or strong bonds? Weak bond. So, why this type of bond significant to the DNA? Think about something that we're gonna talk about it today, which is something related to replication. So why do you think it's easier to separate? Excellent. So as we said, hydrogen bonds are what? Weak bonds. So it will be easy to separate them. So that will be help in DNA replication. DNA replication, which means like we want to make more copies of DNA. Clear? Raise your hand if it's clear. Fist to 5. A, can we, yeah, thank you. So we have the strands of DNA. The strands of DNA are complementary or identical? Please raise your hand. Complementary. So they are not identical. So A will not bind with A. A will bind with T. C with G, not G with G. So they are complementary. And we said replication means what? Copy. Making copies of DNA. So we're gonna have like daughter cells that have the genetic information from the parent cell. And as we said, cell must replicate its DNA before division. So what do you think, which phase the DNA replication happens? It says before division. So which phase is it? Yes, interphase. So it is before division. So it is the interphase division. Excellent. So the DNA replication, to give you a general idea, we're gonna watch a video right now. So it is, we call it semi-conservative. So we have the parental strands, they are not degraded. There will be a parent strand serve as a template. So that we're gonna have a new strand connected with the parent strand. Okay? So it will not be degraded. Let's watch this video to make
and it's replicating its DNA. You know what it's not doing at the exact same time? Dividing. You don't want a cell to be replicating DNA and dividing at the same time. It's a little bit too much multitasking. So DNA replication does not happen during cell division, otherwise known as mitosis. In fact, cells replicate their DNA before division processes like mitosis and meiosis, Because once you make the new cell, you better have DNA to put in there. I think DNA replication would actually make a great video game. It's actually quite exciting. I'm going to introduce the key players in DNA replication so that you
Remind me of the name of the kid that got the technical award.
So,
That was your student.
going back to your question about the, if we have A binds with T, so what will happen if A binds with G? So as we said, they are responsible for what? We're doing this for what? For the protein synthesis. So, if we have something
They're gonna do
that
a page on
doesn't
just in
match,
science.
incorrect, yeah. So we're gonna talk about it later about the mutation. So we have something called mutation, gene mutation. When we have, it could be like adding or deleting nucleotides. So that will affect the protein. So what I'm gonna give you now is the this mind map. So you have the word bank, okay, and it's useful so you can match the word with its definition or the function. Okay, so if you could please take one and pass it. So you will take I think 5 minutes. Okay, 5 minutes and then we're gonna discuss it. So you have the word bank, okay? If you did this at home, please, when you're done, raise your hand. So I know that you're done. Okay, so you're almost done. So guys, eyes on me. So, DNA code around what?
Genes.
About around.
Histones. Told you. I
So
swear.
yeah. As we said, histone is a protein that DNA coils around. Okay? To make a space, to condense. So, DNA shape is what? Raise your hand. Yeah. Double helix. DNA made of what?
Nucleotides.
Nucleotides. Yes. The nitrogenous bases, as we said, guanine pairs with what? Cytosine. And thymine pairs with what? Adenine. And we said the backbone are two things. Phosphate and raise your hand please. And sugar. So going back to the replication, as we said, replication, making like what? Copies of DNA. So just I need you to have a general idea about the replication for the next class. So I want you to remember the main 3 enzymes we have in the replication. We have helicase, the one that is in the blue color. And we have polymerase and we have ligase. So helicase, the enzyme, do what? Let me use the book. Where is this structure? So helicase enzyme. What is the function of the helicase enzyme? Opens up the DNA. So it's, in another word, we could use like it unzip the DNA. Okay, so prepare it for the replication. So where is the function for the polymerase in general?
Extends the primers and it's added on.
Added what?
The 3 inch.
3 prime.
3 prime. Yes.
So it adds what? In general. Guys. So it adds what? Nucleotides or add nucleotides. So what type of nucleotides? It could be what?
Adenine, thymine, cytosine.
Okay, great. Thank you. Notable. Thank you. Okay. What is the last enzyme? We have ligase. So what is the function of ligase? Remember from the video?
It seals the gaps between the DNA fragments.
Yeah, excellent. So it's good one. So it's what? It heals the gap
Yeah.
between the nucleotides. So its function as like what?
They just seal
The
it.
glue
Yeah,
thing. So it stick the nucleotides together. Sorry? Show you the picture for the replication. Are you singing that? So,
I remember this.
So we have, so as we said, this is the DNA. How many strands of DNA? How many strands for DNA? Is it single or double strand?
Double.
Double stranded DNA. So we have 2 strands. So, 2-stranded DNA. So, during the replication, we have the first strand, we call it leading strand, which is on the top. And in the bottom, we call it lagging strand. So, leading strand is the continuous strand. So, the DNA polymerase will add nucleotides continuously. To do now, you're gonna open your Schoology and log into your Schoology, and you have your exit. It is a small, short animation for the DNA replication with 5 multiple choice questions. So, what you're gonna do is watch the short animation, then answer the 5 multiple questions. Take your time, okay? We only have 8 minutes. 8 minutes, good. So I think you need only 5 minutes. So, when you're done, submit your answers. Take a screenshot for your result and submit it on Schoology.